Okay, welcome again. This is the continuation of the previous introduction where I was introducing you double integration. I said that double integration means integration in two dimensions. So suppose you want to find out the density of a elliptical plate. Okay. In my previous video, I had explained you that you can do the integration on the vertical strip. Now in this case, I'm going to explain you that what will happen if you take the horizontal strip. Suppose on this region, you want to do this integration. So fxy dx dy represent the density on this rectangular patch. Now you want to integrate it on the area of this uh, elliptical region. So here I'm taking the horizontal strip. So if I'm taking a horizontal strip, as I told you in my previous lecture, that the first integration is this, which is always the integration on this strip. Now here in this case, a strip is parallel to x-axis because it's a horizontal strip. So this limit will be x is equal to x is equal to. So suppose this point is y is equal to c, this point is y is equal to d, and this curve is x is equal to f1y, this is x is equal to f2y. So my strip start from x is equal to f1y goes to x is equal to f2y. My first integration will be on the strip. So when I'll be doing the integration on the strip, there will be variation only along x-axis. There's no variation along y-axis. So I have to treat y as a constant quantity. So I'll be doing my first integration on this strip. I'll be doing first integration with x. Remember, many times people get confused by this dx dy. They think that with respect to which I have to integrate. Remember, with respect to what you have to integrate is always judged by what variables limit is this given to you. This is the limit of x variable or this is the limit of y variable. If this is the limit of x variable, that means you are given a horizontal strip. So you are supposed to integrate first with x. While doing this integration with x, you will be treating y as a fixed quantity or constant quantity. So you will be first integrating along with x-axis. So you will be integrating first on this strip. That means like these rectangular patch, so many you are going to do, and on all of them you are going to calculate that and you are adding. That's what the general idea of integration. And then after doing the integration on this strip, you will be moving this strip along the y-axis, bounded between this part of the curve, and this part, left part as well as right part, So first you will be first integrating on this strip, then you will be moving the strip from y is equal to c to y is equal to d. Remember, these limits in the double integration are always contains variable. Sometimes it may be constant as well, but if it is constant, that means my region of integration is rectangular, because if it is a rectangular region, there will be always x is equal to constant, y is equal to constant, because those will be straight lines, will be the boundary of that region. So only in that case, this all limits will be constant. Neither in majority of the cases these limits are the functions, because we always bound the strip from one curve to the another curve. So this is the horizontal strip. We are bounding it between these two regions, from x is equal to f1y to x is equal to f2y. So first I'll be integrating with integrate with respect to x and treat y as constant. Then you will be integrating first with x I'm sorry, y is equal to c2, y is equal to d. First you will be integrating. So suppose you got some function. Don't get confused by the previous one that I have written capital F. I'm just writing this function's integration is this function. That could be any function coming over here. So x is equal to f1y to x is equal to f2y. You will be substituting in it. So this will be entirely a function of y, which you are going to integrate from c to y is equal to d dy, and that will give you a constant. So that's the idea about the horizontal strip. You can take the horizontal strip in the same region, you can take the vertical strip. Now the question arises, in what kind of region, what kind of strips we should take. Now here you have to be smart. You have to be smart means they are the reasons in which you have to take the horizontal strip. Sometimes the reason demands it, that you should take horizontal strip or you should take vertical strip. What I'm saying reason demands it means that sometime it happen that with the horizontal strip my integration becomes simpler, whereas with the vertical strip it become complicated. So I always prefer in that case which kind of a strip is much comfortable. So reason demands us to take horizontal, we'll take horizontal. In some cases the integral function which is given to us to integrate, its integration with the vertical strip is become tough, because when I'm doing integration with vertical strip, remember I have to do first integration with y variable. Whereas if I'm doing integration along the horizontal strip, I'll be doing first integration with x variable. So depending on the function and depending on the reason, we decide whether we should take horizontal strip or vertical strip. Thank you.